Hi, folks. Can you hear me?
Hello, sir.
Oh, hi, Jake. All right.
Yeah, good, thanks.
Good. Right. So it's obviously all working. Hi, Avery. Can you hear me okay?
Yeah, yeah, I can.
Yeah, good. Hi, Guy.
Hi, sir.
Are you all right?
Yeah, good, thank you.
Right. Let me just get my act together here. Um, okay. So, yeah, that's the right one. Right. So here's some info for you on the paper. So you might want to jot down the grey boundaries that are relevant to you. And this is the first paper of two, and we're doing the second one next week. And I thought we could this time start at question, which one was it? Yeah, I think if we start at question 8, then we miss off the first 30 marks, and we'll do those at the end. And that just means that we'll spend longer on the harder questions this week rather than so long on the easy questions. So I hope that's okay with everyone. Hi, Will, can you hear me?
Hi, sir.
Hi there, all right?
Yeah, good, thank you.
Good. So starting on question 8, folks, okay? But we're still a couple of minutes early, but it doesn't matter. There's no reason why you shouldn't make a start.
Could I have a link to the paper, please, sir?
Yeah, of course you can. Um, if you go onto the system, you know you can get it a week early. Oh, all right, here's the paper. Oh, yeah, there it is. That should work for you, Guy, okay? Hello, everybody. Right, who's arriving? Hi, Thomas, you okay?
Yeah, I'm good, thanks. How are you?
Cool. Yeah, fine, thanks. Um, so there's some info on the screen for you. Hi, Matilda. Earth calling Matilda. Can you hear me okay? Well, I hope you can hear me, Matilda. Maybe your mic isn't working. Send me a chat if you can. Hi, Genevieve, you all right? Can you hear me, Genevieve?
Yeah, sorry, my
Oh,
mic
brilliant.
went
No, that's all
on.
right. Cool. Oh, hi, Matilda. That's good. Matilda, you're very welcome to talk or just send me a chat. It doesn't matter which. Okay. Hi, Ria. Are you happy? Earth calling Ria. Eva. Talk to me, Ria. Okay, Ria, you do that then. Right, Eva, can you hear me? Beatrix, can you hear me? Oh, Eva sent me a note. Oh, good. Right, Beatrix, can you hear me?
Yes, I can.
Oh, brilliant. Hurrah. Good.
Sorry.
Okay. Right, now, everybody, you can see the grey boundaries for this week's paper on the screen. Okay. Hi, Beatrix. Oh, there you are. That's good. Thank you for turning on your camera. You can see the grey boundaries on your screen. So write down the ones that matter to you, and then you can tot up your marks as you go along. All right, we're going to start this week from question 8. Okay, and that means that we'll hit the end of the paper and we'll be able to spend longer on the second half of the paper this week rather than longer on the first half of the paper, which we did last week. Okay, so start on question 8, but that doesn't mean that you can't bail and just go to the beginning whenever you feel the need. All right, and if you are new, then please know that it helps me if you're happy to turn on your camera, but I will survive if you're not going to do that. And also you can just shout out at any time or send me a chat if you'd rather not speak aloud. Oh, Eddie, first of all, you moved it to your ceiling and now you turned off your camera. Oh, hello, he's back again. Right. So we're starting on question 8, folks, okay?
Is it okay if you show us which one it is just to check I've got the right paper?
Yeah, of course it is. Of course it is. This is my question 1. It's on mixed numbers. Is that your question 1?
Oh yeah, I've got that. Thank you.
Brilliant. Okay. Hello, Rachel. Oh, hello, Rachel. No, sorry, it's not Rachel, it's Jessie. I thought I wasn't sure who Rachel was. Hi, Jessie. Right, there are the grey boundaries, Jessie. So write down the ones you want, quick as you like, because we've got to get started.
Okay.
And everyone, we're starting from question 8, okay? Starting from question 8. Hi, Ed. Earth calling Ed.
Hi, sir.
Hi, you right?
Yeah, good, thank you.
Good. Jot down the grey boundaries you want from the screen, okay? And then we're going to start on question 8 this week,
Okay.
which is about somebody buying a boat.
Yeah.
Now, if you're at all unsure about what's going on or you want me to get you started on a question, just ask me, okay? I'm going to give you a bit of chance to get ahead of me. But just talk to me and I'll help you out. Does anyone need a link to the paper? Has everybody got what they need? Hello, Rohays.
Hello.
Oh, hi. Are you okay?
Yeah.
Good. We're starting on question 8, Rohays, this week, okay? So we're going to do the beginning of the paper at the end, all right? So question 8. Anybody want me to get them started on 8, 9, or 10, or anything else? Just ask me. Hi, Ria. Is everything working this time? If your mic isn't working, Ria, then as long as you can chat, then maybe we just put up with it and you can get on with some work. There you are. There's my number 8 on the screen. when you do a percentage decrease, you multiply by 0 point what's left. So every year, I multiply by 0.92 because I'm reducing by 8%. Get the answer off my calculator. Write it to the nearest dollar. Please ask me if it doesn't make sense. Hi, Herbie, are you okay?
Hi, sir. Sorry, I had troubles with the link getting
That's
on.
okay. So I've just done number 8, Herb, so we're kind of on 9 or 10 now, okay? We're starting halfway through the paper this week, and we're doing the beginning of the paper at the end. Anybody want me to get them started? Please talk to me. Sorry. Oh, Ria, you've made it. Good. We're on question 9 now, 9 and 10.
Okay. Yeah.
All right. So you carry on from question 9 if you want to.
Sorry, I had to join on my
Don't
iPad.
worry.
It was like
Don't
this
worry.
flexibility thing.
No problem.
Because it's better if you can see me then.
It's better for all of us, Ria, yes.
Sorry, what question are we starting on? Because
What-
we're not starting on the.
No, 9 or 10. I'm going to do number 9 in a few minutes.
Okay.
So in this one, the area of the whole shape is the area of the triangle plus the area of the semicircle. So this is what I get on the screen. But if something doesn't make sense, then talk to me. See, I've written 4.2426 here. It's probably better to be using 3 root 2. But when you do 3 root 2 squared on your calculator, make sure you put it in a bracket so it squares the 3 and the root 2. Now, is that looking all right? Does anybody want to ask anything about question 9? I'm guessing people might want a starter on 10 or 11 or 12. So let me know if I can help. Nobody wants a hand with 10, 11, 12. I'll be quiet for a bit.
Can I actually have a starter on question 10, please?
Yeah, of course you can. So anybody else who's stuck on question 10, you might want to watch this, okay? Let's ignore their number and let's just look at this. 2 to the 3 times 3 squared times 5, just a made up number, okay?
Wait, where
So-
have you got the 2 cubed from if it says 2n?
No, just ignore all that.
Oh, okay.
I'm just doing some maths on the screen, okay?
Okay.
All right. So if you had that red number, Ria,
Yeah.
and they asked you to work out to double it, to times that red number by 2, what would you end up with if you times the red number by 2?
For
No, you've got a 2 to the 1 here, haven't you? Yeah.
2 to the power of 3.
Well, you've got 2 to the power of 3 already. So now it's going to be 2 to the power of 4. Because remember how you
wait.
add the powers.
I thought if it was 1, that's just the same. It's just 2.
It is. Right, okay, stop.
I'm really
Stop.
confused.
Right,
Sorry.
all right, relax. Relax. Have a look at this. What's x to the 6 times x to the 2?
X 5 8.
Nice, you add the powers, don't you?
Yeah.
What's 2 to the 2 times 2 to the 3?
2 to the power 5.
Nice, you add the powers. What's 2 to the 1 times 2 to the 3?
Oh, 2 to the power 4.
Nice, you add the powers. Happy?
Yeah.
Right, so now let's go back to this question. Here's a red number, and I want you to times the red number by 2. So to do that, we say, oh, 2 to the 1 times 2 to the 3 is 2 to the 4, and then we'd copy down the rest.
Okay.
So this number is double the red number.
Yeah.
Good. Right, now let's continue. Now let's imagine that instead of timesing the red number by 2, we were going to times the red number by 10.
All right.
Now, if you were going to do that, you know how 10 is 2 times 5?
Mm.
So in fact, you'd be doing 2 times 5 times the red number.
Oh, okay.
So now you'd have 2 to the power of what?
Um.
You've got 2 to the 1 here, 2 to the 3 here. Add the powers.
Oh, 2 to the power 4.
Nice. And 5 to the power of what? You've got 5 to the 1 here, 5 to the 1 here.
5 to the power 2.
Nice. Well done. Okay.
Or 5
Happy?
squared.
What?
Or you could say 5 squared.
You could do, yes. Right. Now let's have a look at this one. Let's imagine you were going to do 8 times that number. I've forgotten what that number was. So it doesn't really matter what it was. Let's imagine you were doing 8 times this number here.
Okay.
Now 8 is 2 times 2 times 2, right?
Yeah, so 2 to the power 3.
That's right. So what we're doing really is 2 to the power of 3 times that
2.
number.
Yeah.
So what are we going to end up with now? 2 to the power of what?
6.
Times the rest of the number.
3 times.
So can you use that logic to do the question they want you to do?
Yeah.
They want you to work out 8 times 2 to the power of n times 3 times 5 to the power of m.
Okay, I understand now. Thank you.
Good. And I'm guessing, because you asked, lots of other people were happy to listen as well.
Okay. Okay, thank you.
So I'm going to do that on the screen now, and people can look when they're ready. There's my answer when you're ready for it.
Please, can I have some help on question 14B?
Of course you can, Rohase. Yeah, 14B. Oh, see what you mean. Now, do you know what this means?
No.
That means C is a subset of A. Now, Rohase, do you know what that means?
Is it where everything in A is part of C as well?
No, it's where everything in C is in A. Okay?
Okay.
So so everything that is in C is in A. So if this is A, look, then C fits all inside it. Okay.
Okay, thank you.
Does that help you suss it out now?
Thank you.
Probably. Cool. Now, remember on 11, remember the 3 stages. First thing you're going to do is work out the upper and the lower bound of each of the numbers. In this case, A is 6 correct to the nearest integer. So the upper bound is 6.5 and the lower bound is 5.5. Now, trick coming up. When it says that B is 15 correct to the nearest 5, some people think, oh, I don't know how high to go, and maybe they go 20 and 10, right? Now, if you have gone 20 and 10, then you've got it wrong, but it doesn't matter because you're going to get so many follow-through marks, assuming you've carried on. So always carry on. But the way to get the upper and the lower bound correct when it's something like to the power of 5, to the nearest 5, is to halve what it's to the nearest to. So half of 5 is 2.5, and then go 2.5 up and 2.5 down. So actually, the correct upper bound is 17.5, and the correct lower bound is 12.5. But if you didn't get those, then you're only going to lose a mark as long as you've done the other 2 stages. This is the next stage. Write down the formula. And then decide, if we're having the upper bound of C, decide which B you want and which A. Now, if you want C to be as large as possible, you want the largest possible A minus the smallest possible B. So write that down like that, and only now for stage 3, go ahead and work out what that is. 17.5 is the largest possible B. 5.5 is the smallest possible A. So the largest possible C is 12. Okay, do you see how there are 3 stages? Do each stage separately, and you'll get all the marks you possibly can. Now, everybody is very quiet, so I hope you're happy. If you're not, send me a chat or talk to me.
Do you mind if I have a couple of minutes before I work on talk? Because I'm on the last bit of it.
Yeah, I'll just tell me to stop. I'm glad you told me to slow down. I'll just stop. It's fine.
Okay, sorry.
No, don't worry, Ria. It's fine. Nobody minds. I'll just be quiet for a couple of minutes. Just don't let me go too quick.
I've done number 12 now.
Okay, cool. You carry on. I'll let everyone get a bit ahead.
Okay.
And nobody's asked me for any help on number 12. So this is my answer. Of course, I can explain how I got it if anybody wants me to. But when I factorize these, what I'd do is I'd just check that I'm going to get the right number of x's. That would give me minus 4x. That would give me minus 3x. So yeah, altogether it's going to work, isn't it? Minus 7x. But if you want to know how to get 12a, just let me know and I'll help you.
How did you get that?
Oh, hurrah. Who was that? Was that Isabel?
Yeah, that's
Oh, good. I'm pleased somebody asked as well. Right. So this is how I did it, okay? I knew that it had to be that. I knew it was 2 brackets. Yeah? Take yourself off mute so you can answer me, Isabel. Happy it's 2 brackets? Was that a yes?
yeah, sorry, it
Okay,
was.
right, okay. Now, you know how the first, we got 2x squared there. But
Yeah.
it's not going to be x and x, is it? Because that would give me x squared. It's going to have to be x and 2x squared. And 2x, sorry, because that's the only way I'm going to get 2x squared. You happy with that?
Yeah.
And now my signs. I know they times to a plus, but they add to a minus. So I know it's got to be minus and minus.
Okay. Oh yeah,
And
that makes sense.
now it's just a question of trying out, or for me, my method, you just try out numbers until you get it right. Now you know
Oh,
they've got to multiply to 6, right?
yeah.
So you could try 1 and 6. Do you agree?
Yeah.
Now, if you put in 1 and 6, that's going to give you 2x squared, and it's going to give you plus 6, but will it give you the minus 7x? So all I
No.
do is I do my rainbow and my smile. Okay, it's very cute, isn't it? Okay,
Yeah.
so the rainbow gives me minus 6x, the smile gives me minus 2x. Ah, that's minus 8x. That's not right. So I just carry on trying stuff out until I find something that works. All right?
I see.
Minus 2x, minus 6x, that doesn't work. Try it the other way. Try a 2 here and a 3 here. Minus 3x, minus 4x. Yes, it works. You happy with that?
Yeah. Okay, I see.
All
Thank
right.
you.
There are other methods, but I would just puzzle it out.
Yeah.
Okay, now this one here, I'm going to multiply both sides by 3.
Can I have help on question 13C, please?
Say that again, Ria?
Have some help on question 13C, please.
Yeah, okay, I'll just finish this one and then I jump onto 13C for you.
Okay, thank you.
Times the left by 3, times the right by 3. Now I've got m's on both sides. See which side has the fewest and get rid of them. I've got minus 6m there. That's the fewest. So I'm going to plus 6m to both sides. Gives me 10m plus 9 equals 21. Subtract 9 from both sides. 10m equals 12. Divide by 10. M equals 1.2. Right. Where am I going, Ria? 13C?
Yeah, thank you.
Okay, well, I'll tell you what, you carry on. Have a go and carry on because I'm going to do 13C pretty quick.
Okay,
All right?
okay. Thank you.
No, don't worry. Right. Okay, I'm looking at this one now. The 4th root of y over y. Now, the secret here is to realize that the 4th root of y is y to the power of a quarter. So I've got y to the power of a quarter divided by y to the power of 1. And when I divide, I subtract the powers, don't I? So you're going to end up with y to the power of minus 3/4, because a quarter take away 1 is minus 3/4. Ask me a question about number 12 if you want to, or about anything else.
So, how would I start question 15?
Good question. Let's have a look. Ah, right. So this is a kind of, you either know how to do this or you don't, Will. And this question comes up every now and again, but the topic's not connected to anything else. Okay? So there's just a fixed way of doing this, and this is what you do.
Okay.
You say x equals, you leave a gap. I'm leaving a gap here. You'll find out why in a minute. You leave a gap and you write down 0.254. Now this dot dot means 545454. You probably knew that.
Yeah.
Okay, good. Now, don't write this down, but if I were to write 10x underneath that, then 10x would be 10 times this, right?
Yeah.
So that would be 2.545454. Get the idea?
Yeah.
Now, the reason we're not going to do 10x is because it doesn't line up the equal digits. Do you see
Okay.
how? Yeah. So 10x was a rubbish idea, but I always try it first because I never quite know what's going to work. So let's try 100x this time. You can write this one down because it's going to work.
Okay.
Now 100x. Now we're going to write down 100x, but we're going to line up our decimal points. So that's going to be 2, 5, and then it's going to be 4, 5, 4. Look at that. They're lining up.
Yeah.
All right. Okay. Dot, dot, dot. Now, draw a straight line there because we are going to do the 100x line minus the 1x line.
Okay.
Do the bottom minus the top, right?
Yeah.
And this is what's clever about this. You know that 100x minus x is 99x, so that's easy. Equals. Now, I want you to imagine you're doing a subtraction sum. Start here.
Okay.
Remember, we're doing it's slightly confusing. We're doing the bottom minus the top, right?
Yeah. Okay.
4 take away 4, it goes. 5 take away 5, forget it. 4 take away 4, forget it. 5 take away 5, forget it. 4 take away 4, forget it. 5 take away 5, forget it. 4 take away 2 is 2 decimal
Yeah.
point. 25 take away nothing is 25.
Yeah. Okay.
Look at that. 99x equals 25.2. Divide both sides by 99. And then put that in your calculator and press equals, and it will tell you it equals 14 over 55.
Okay. Thank you.
All right. I hope that helps somebody else as well.
I did 10x, but I still got, and then I got 990, but I still got 14 over 55.
I see. I think you did. Did you do 10x and 1000x or something?
Yeah.
Yeah, that's fine.
Okay. I was just checking that I did.
That's not a problem. You did it perfectly well.
But I still
Okay?
get the same marks as how you did.
Absolutely. Absolutely.
Okay. Thank you.
Now, nobody's asked about this probability tree. So is everybody happy about filling in the probability tree? Everyone knows what to do. So group C has got 6 girls and 8 boys. So the chance of getting a girl is 6 out of 14. And the chance of choosing a boy, selecting a boy, is 8 out of 14. So that's my child picked from group C. Next, I have to pick a child from group D. So I wander over to group D and I look at group D, and there are 3 girls and 7 boys. So that means the chance of getting a girl is 3 out of 10. Chance of selecting a boy is 7 out of 10. Here we go, 3 out of 10, 7 out of 10. Now that is the probability tree diagram completed. Does anybody want to ask anything about that? What's the probability that there are 2 boys in the team? Well, that's the probability of ending up here, isn't it? Boy, boy. So remember, you multiply 8/14 multiplied by 7/10. Stick that in your calculator and you'll get your answer, which is 2/5, I think. Okay. Now, next. Please, I hope somebody's telling me to stop if they're not ready for me to do this.
Can you write it as like 0.4, or does it have to
Yeah,
go for
absolutely you can, Genevieve. No problem at all.
Okay.
Right. Now, so the probability, right, let's read this one then. After the first team has been picked, okay, we've picked the first team, okay? So we've got to here, all right? After the first team has been picked, a second team is picked, okay? When we pick the second team, we pick at random from the children left in Group C, and then the second child is picked at random from the children left in Group D. So we kind of go back to Group C again, and then to Group D again. Work out the probability there are 2 boys in each of the 2 teams. Well, we could start from the beginning again, I guess, couldn't we? We could start from here. So we want to get a boy in the first, a boy here, and then yes, he could get a girl, but we don't want that. We want a boy here. And that is the first team chosen. So that's here. Okay. Then we choose again from Group C, and we want a boy, don't we? And then then having chosen a boy, we could then choose a girl, but we don't want to do that. We want to get a second boy. Look at that. That's what we want. This is the tree diagram, and we want to get down here. Choose a boy, then a boy. Choose a boy, then a boy. That's what we're after. Now, we already know that the probability of choosing a boy from Group C at the start is 8 out of 14. And then the probability of choosing a boy from Group D for the second boy, second choice, is 7 out of 10. Now we go back to Group C, right? Back we go to Group C. What's the chance of getting a boy there? Well, there are only 13 people left in Group C because I've chosen one of them here. And of those, 7 of them are boys because there used to be 8 and I've chosen one already. And then I go to Group D again. Now in Group D, there were 10 people. Now there are only 9. And 7 of those are boys because it used to, sorry, 6 of those are boys because it used to be 7, but I've chosen one of them. So what's that going to be? It's going to be 8 out of 14 times 7 out of 10 times 7 out of 13 times 6 out of 9. That's what it's going to be. If you realize you've already worked that out as being 0.4 or 2/5, but it doesn't matter if you don't realize that. You can times all your fractions together. And I got a pretty weird answer. I think it equals 28, I know it does, out of 195. All right. And the most difficult bit of the question for me was reading those words and understanding what it wanted me to do. Ask me a question if you want to. Right. Is everybody okay what this means in number 14? For instance, what this means here. Or what this means. The first one, the A, that means that the numbers in A are those that are less than 12. So that must be the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12, right? And then this one, that means all the numbers. Does it include 7? 7 is less than or equal to x is less than 16. It does include 7 because 7 can be less than or equal to 7, but it doesn't include 16. Is that okay? Doesn't include 16. So that's all B. And so here it's saying the members of A intersection B. So the numbers which are in A and also in B. So you should have 7, 8, 9, 10, and 11. Right. Set C is a set, so that C is a subset of A. So everything in C is also in A, right? So here's A with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12 in it. And everything in C is also in A. Oh, look, there are 3 members of C, and all the members of C are even numbers. So C must have 3 numbers in it, and they're even numbers in A. So any 3 even numbers from A would do. You could have said 8, 10, 12. Or you could have said 2, 4, 6. It doesn't matter. As long as you've said 3 even numbers, which are less than or equal to 12. Is that okay? Nobody's talking to me, so I hope you're happy.
Sir,
Yeah. Ed.
I've got a question on 19.
Okay, crikey. Wait a minute. Wait a minute. Let me go up to 19. Okay, I'm ready.
To work out the frequency density to do the graph, don't you have to do the, I was just checking that you have to divide the frequency by the height in meters, isn't it?
You divide the frequency by the class width. So this one, 0 to 20, is a distance of 20, isn't it?
Yeah.
So the frequency density in this case is going to be 15 divided by 20.
Okay.
Okay, now this next one, that class width is 15, right?
Yes. Okay. Yeah.
So it's going to be 48 divided by 15.
Yeah. And then the basically, yeah. Okay. All right. Perfect. Thanks.
Okay. Now, the formula to work out the sum of the first 100 terms of the sequence, the total of the first 100 terms, is given to you on the formula sheet. Here it is. And so the thing that you need to do with this one is to remember what you substitute in for n, what you substitute in for A, and what you substitute in for D. So we're adding up the sum of the first 100 terms. So the n is 100. So it's that. 2 times a, well, a is the first letter of the alphabet. So a is the first term of the sequence. So that's going to be 2 times 7 plus n minus 1. Well, I know n is 100, so n minus 1 is 99. Times, and d is the difference between the terms. So the d is a 3. And then you can just put this in your calculator. 50 times, open a bracket, 2 times 7 plus 99 times 3, close your bracket. And you'll get your answer. I got 15,550. Nobody's talking to me, so I hope you're all doing okay.
Can I have some help on question 20, please?
Yeah, of course you can. Oh my gosh. Oh, did we do one of these the other day, Rose? Did we do one of these last week, I think? Let's have a look. Okay. What circle theorems are you thinking of when you see that diagram?
I think angle ABC is 71. Is it the alternate segment theorem?
A, B, C. Now it would be, but the alternate segment theorem, you remember the alternate segment theorem is all about somebody windsurfing.
Yeah.
Do you? Yeah?
Is it only triangle?
Yes, that's right. The windsurfer, the sail's a triangle, right? You'd never be able to hold up a rectangular sail, it'd be too big. So we need a triangular sail. So here's my hint. My hint is do that. Do you see what I've just done?
Yeah.
And now I think if you draw your windsurfing person here, now let's have them look down at their feet. So which angle is going to be equal to the 71?
ABD?
Correct, because they look down at their feet and up at the sky. So that angle is 71. And now I think you might be on your way.
Thank you. Does it always have to be a triangle?
Yeah,
do you have to
because
make it into a
windsurfing. Have you never windsurfed, Isabel?
No.
Okay, well, nor have I. But yes, you have to imagine the windsurf sail as a triangle.
Okay,
So
thank
if
you.
you've got, so sometimes you have to add your own line. We had to add our own line on the last week one, I think, didn't we? Or the week before? Can't remember.
Yeah, I think we did.
All right.
Can I have some help on 17?
Yeah.
Thank you.
Let's have a look at 17. Okay, now. Okay, so I'm on 17 as well. Now, for everybody, my tip on 17 is whenever you see it's a question like this, always do this. We're going to give ourselves a table here, okay? In the first, we're going to have small, which happens to be shape A, and we're going to have big, which happens to be vase B. Okay?
Oh, okay.
Do you remember this? Have we done this? I think this came up the other week, but perhaps you weren't. I don't know if you were with us or not. So, small and big, right?
No, I've seen my teacher do something like this.
Okay. Right. So, and then we're going to have 3 different measurements. We've got lengths, we've got areas, and we've got volumes, right?
Yeah.
Now, fill in what you know.
Okay.
I know a length for A is 24.
No, but that's height.
Yeah, well, who cares? It's still a length. It's still a linear
Oh,
measurement.
okay, right.
Do you see what I mean?
Yeah.
It's a distance. It's not an area and it's not a volume. Do you get it?
Yeah.
Okay. So it's kind of, I suppose I could have written linear here, but I would think that sounds a bit complicated. But basically, it's just a length. I know it's the length up, but it's still a length. and this one's 36. You okay with that?
Yeah.
Okay. Oh, by the way, I can instantly work out what the scale factor is here.
Oh yeah.
36 divided by 24. It's 1.5, isn't it?
5. Yeah.
Brilliant. Okay, so we know the lengths of the big one are 1.5 times the lengths of the small one. Happy?
Yeah.
No, I didn't do what I said because I said fill in everything you know. We haven't filled in this 960.
Okay.
Now that is the surface area of the small one, isn't it? 960.
Oh yeah.
Go on.
Oh.
What are you going to...
I was gonna put, I don't know if this is right, but you know how volume says VC centimeter cube? I was gonna put that in the thing, but I'm not sure if that's right.
Well, oh yeah, but let's do part A first.
Oh, okay.
Yeah, but you're right. We're going to do that in a minute. But let's do part A. Now, do you see how the lengths are 1.5 times bigger?
Yeah.
Does that mean the area is going to be 1.5 times bigger?
Oh yeah. So the area is going to be 960 times 1.5.
No, it's not.
Divided.
It's going to be 960 times 1.5 squared.
Oh yeah.
Because you remember how the linear scale factor is 1.5, so the area scale factor will be that one squared. Oh, by the way, what would the volume scale factor be? 1.5 cubed.
Oh, okay, yeah.
Okay, and this boils down to this, right? Ria, here's your bedroom. Okay, rectangle.
Yeah.
Sorry, Ria, here's your prison cell, right? Little rectangular prison cell. Okay, happy?
Okay. Yeah.
Now let's say you get a double, for good behavior, they move you into a cell which is double the size.
Okay.
So it's double the length and double the width.
Okay.
Do you see how it's 4 times the area?
Oh, yeah.
Yeah? And in the same way, if you double the length, width, and height, then the area would get 8 times bigger. You see, the scale factor that's what happens.
Oh, okay.
So if we the new area isn't going to be 960 times 1.5. It's going to be 960 times 1.5 squared. It's actually going to be 2.25 times bigger.
Oh, okay.
So that gives me my answer for A, which is 2160.
Oh, all right. Okay.
Now, I'm going to carry on with part B now. Because you said, oh, shall I write V in here, didn't you?
Yeah.
Now, let's do that. Let's write V in there. Now,
Okay.
how will you, and then what it's saying is find the volume of A. So it wants you to find this. Now, to go from the blue to the yellow, you'd multiply by 1.5 cubed. So how will you go from the yellow to the blue?
Would I divide by 1.5?
Yes, you absolutely would. So the volume of the small one will be the volume of the big one, which is V, divided by 1.5 cubed.
Yeah.
All right.
Okay. Can I have some help on question 18?
Yeah, now. Okay, everybody. So question 18 now. It's not a right angle triangle, right, Ria?
No.
So it's not Pythag, it's not SOHCAHTOA. Happy?
Yeah.
So it must be sine rule or cosine rule.
I will.
Okay? Now, the sine rule, you can only use the sine rule when you know a pair. For example, you know this angle, so
Okay.
you'd have to know that side.
Yeah,
You
which
don't know that pair. You know this you know this side, you'd have to know that angle, and you don't. You know this side, you'd have to know that angle, and you don't. So you ain't using the sine rule. Is that okay?
Yeah.
So you have to use the cosine rule, right?
Yeah.
Now, here's the cosine rule on the formula sheet.
Okay.
Can you see how the cosine rule is apparently all about a squared?
Yeah.
And this is a. Yeah?
Yeah.
And to find a squared, look at the diagram. You need to know b to get b squared. You need to know c to get c squared. And you need to know this angle. So you can do cos of a, look. Okay? So the cosine rule works really well when you know an angle and the sides either side of the angle. Do you see how B and C are either side of the angle? Do you see how they're kind of like that?
Yeah.
Okay, so let's have a look at our picture here, our diagram. Oh, look. We've got the angle in the middle, and we've got that side and that side.
Oh, yeah.
Perfect. So PR squared is going to be, it doesn't matter which way around those sides are, 17.8 squared plus 26.3 squared minus 2 times 17.8 times 26.3 times cos 36. I'm wishing I'd written out the formula to show it to you, sorry. But it is that squared equals b squared plus c squared minus 2bc cos a.
Yeah.
The important thing is that it's the two sides and the angle in between them.
Yeah.
And now you can just shove that into your calculator.
Oh, okay.
So I'll do it and write down what I get. You can do the same if you want to.
Okay.
So,
Yeah, hi.
do you think I can get some help on question 21?
Yeah, of course you can, Beatrice. Let's have a look.
Thanks.
Oh my God. Right. So, what have you done so far?
Nothing much.
Have you read the question?
Yeah.
Right. Well, I'm going to read the question, but I'm going to tick off and label stuff as I go. All right?
Okay.
A solid is made from a hemisphere and a cylinder. I can see the cylinder, I can see the hemisphere. Happy?
Yeah.
The plane face of the hemisphere coincides with the upper plane face of the cylinder. Well, I don't really understand what that means. Well, I do really. It just means they meet like that.
Yeah.
Okay? They're a perfect fit, just like in the diagram. Okay? The hemisphere and the cylinder have the same radius. Well, of course they do. It looks like that on the diagram, doesn't
Yeah.
it? The ratio of the radius of the cylinder to the height of the cylinder is 1 to 3. Wait a minute. So you mean that if that is r here,
Yeah.
then what is that length?
That's 3R.
Nice. Okay, happy?
Yeah.
Tick it off. given that the solid has a volume of 792 pi, work out the height of the solid. Right, okay. We've got to write an equation from this piece of information here, Beatrix, okay?
Yeah.
Right. The volume of the solid. Okay? Now, the solid is made up of two different shapes, isn't it?
Yeah.
To get the volume of the whole thing, we're going to do the volume of the two shapes added together, right?
Mhm.
So I've got the formula sheet on the right-hand side, yeah?
Yeah.
So what do you want to start with, the cylinder or the hemisphere?
We can start with the cylinder.
And what's the volume of the cylinder?
Pi r squared times by h.
Oh my God, she can read. Well done. And what about we're going to add on to that the volume of the hemisphere, right?
Yeah.
Now, the volume of a sphere, I'll write it here for you. This is the volume of the whole sphere.
Mhm.
So what would the volume of a hemisphere be? Just half of it.
Yeah, half of that.
So instead of 4/3 pi r cubed, what will it be?
2/3
Pi r cubed. Very nice indeed. Happy?
Yeah.
And those two volumes added together have got to equal 792 pi. Okay?
Okay.
Now,
Oh,
I don't want to spoil your
I can
fun.
do that.
Can you take it on from here?
Yeah.
By the
Thank
way,
you.
just before you do, just for anybody else as well, remember you know that H is equal to 3R. Okay?
Okay.
All
Thank
right.
you.
Good luck. Now, if you're feeling like these are questions which are, tricky, then try and get part marks, try and take a first step on each one. But if you're somebody who's going, perhaps your target is a 5 or a 6, then at some point quite soon, you're probably going to want to start from the beginning of the paper, okay? And that's absolutely fine, because soon we're all going to be going to the beginning of the paper. But if you feel like you need to start at the beginning, then do. And you can always ask me a question about the beginning of the paper, even if I'm still working on the second half, okay? So everybody must do what works for them. Now, when you draw your histogram here, just be careful you don't mess up the scale. So 0 to 20, it's like that, isn't it? And then 20 to 35 is 3.2.
In an exam, do you think you would draw a histogram with a pen or a pencil?
Well, I would draw it with a pencil because
Yeah,
then I know I could always rub it out. You're not going to lose marks if you use a pen.
yeah.
Okay, but I would draw it with a pencil, but I definitely use a ruler.
Yeah, okay.
Yeah.
Thank-
Some people say you should do your whole exam in a pencil, but I don't know why you'd have to do that. But anyway. Here's my histogram. Right, now in this question here, with Rohay's help, we've already worked out that ABD equals 71 alternate segment theorem. I think strictly speaking, you should say equals TDA alternate segment theorem. You'd have to write alternate segment theorem. You couldn't just write AST. Now, once I know that's 71, was anybody stuck on this? Does anybody want to do it with me? Okay, so this one is also 71 because that's an isosceles triangle. So I'm going to write BDA equals 71 equals ABD isos triangle. Now I can work out this top angle. Well, let's say the top angle, the angle A, the last angle in the isosceles triangle. So that's BAD equals 180 minus 142. So I think that's 38. And that's because there are 180 degrees in a triangle. Now, this is where the next circle theorem comes into play. You see this is a cyclic quadrilateral. And you know that opposite angles of a cyclic quadrilateral add to 180. So you know those two shaded in angles, the one shaded in black, have to add to 180. So you know that was the target angle, wasn't it? BCD equals 180 minus 38, 142. And then you'd have to write opposite angles in a cyclic quadrilateral add to 180. That's how you get your 5 marks. 5 marks is quite a lot. That's half a grade, folks. Okay. Now, I'll be quiet for a bit. Ask me about the first half of the paper if you've moved on to the first half, yeah? Or ask me about anything else you want to.
Can I have some help with 21? I've done part B because I've just completed the square, but I don't understand the rest of it.
With 21?
22.
Oh, 22. Right.
The sign.
Oh, you've done part B. Well done. Yeah. Okay. Does anybody, it might be, Ria, very happy to help you, but just let me ask, does anybody want me to wait so you can have a go at 22? Anybody? I don't want to go too quick for anybody. Okay. I'll do 22 then. Now, everybody happy? Okay. Right. Now, first of all, let's just do a couple of things over here. You know, if you have y equals f of x.
Yeah.
Okay, now, how do we go from y equals f of x to y equals 2 f of x? What's that change do? Do you know?
You've just added another f. Or multiplied that by f.
No, yeah, I've multiplied. So it's not, if before it had been y equals sine of x for sake of argument, now it would be y equals 2 sine of x.
Okay.
Do you know what that does to the graph? Well, it doubles all the y answers because y used to be sine of x and now y is double as much.
Okay.
So if y was 0 before, it's going to be 0 again because twice 0 is 0. If y was 1 before, it's now going to be 2. If y was 0, it's going to be 0 because double 0 is 0. If y was minus 1, it's now going to be minus 2. If y was 0, it's now going to be 0. Oh, look, this is the graph of y equals 2 sine x. Okay? Now, in the next bit, we have to take the graph of y equals 2 sine x, which is the one that we've just drawn in red, and we need to change that to the one that they want, which is y equals 2, not sine of x, but sine of x plus 30. Okay?
Yeah.
So this is a bit like doing this. It's like going from y equals some function of x to y equals a function of x plus 30. And it's all about if you can remember the rules. If
Okay.
the change is in the bracket, then it moves it along. It changes the x coordinates.
Yeah.
It changes in the wrong way. So the whole of the red graph is going to move 30 units to the left.
Okay.
So what was here is going to move there. What was here is going to move there.
Okay.
What was here is going to move there. What was here is going to move there. So the whole thing is translated 30 units to the left. So that green graph is the one that they want.
Okay.
All right. Now, Eddie and Ed and co, some people we've been doing practice of completing the square with. Here's a good example of just getting marks for completing the square. So it's going to be x minus 3 squared minus 9, copy down the plus 10. So it's x minus 3 squared plus 1. I hope you guys got that. Does anybody want to ask me anything about it? And now we're going to use exactly the same logic as before here. It wants us to know, to tell it how to go from y equals x squared to y equals x squared minus 6x plus 10. Agreed?
Okay. Yeah.
But we're not going to use x squared minus 6x plus 10. We're going to use
X
minus 3 squared plus 1.
Yeah.
Now, this is a change outside the bracket, so it shoves the curve 1 unit up.
Yeah.
This is a change inside the bracket, so it shoves the curve 3 units the wrong way, 3 units that way.
Yeah.
So the curve is going to be translated because it's just going to be picked up and plonked somewhere else.
Is that when you have to say translate by vector or not?
Yeah, and here comes the vector. It's 3 along and 1 up.
Oh, yeah.
So it's the vector 3, 1.
Oh, okay. Right. Yeah. Okay. I understand.
Translated by the vector.
Okay. I understand. Thank
Good.
you.
Anybody else want to ask anything about 22?
So
Hi.
could you explain 22b?
Yes. From the beginning?
Yes, please.
So have you learned how to complete the square?
Yeah, a little bit, but I was not very good at it.
So, well, basically, if you want to get, you probably want to practice it, right?
Yeah.
So if you start with x squared minus 6x plus 10, I'm just thinking about this x squared minus 6x, right?
Yeah.
If I do x minus 3 squared, then the nice thing about doing x minus 3 squared, you know how it means this.
Yeah.
So it's going to give me x squared, isn't it?
Yeah.
And how many x's?
Minus 6x.
Nice. And then annoyingly, it gives me a plus 9 at the end, doesn't it?
Yeah.
So I better minus away that 9. Now, look at this. Put this in your head, and now put this in your head. Do you agree that the yellow is the same as the blue?
Yeah.
Brilliant. Are you sure?
So you just add 10. Oh, okay.
So now I copy down the plus
Yeah.
10. And now I can look at that and go, oh, okay, it's x minus 3 squared, and then minus 9 plus 10 is plus 1.
Oh, okay.
So that was the completing the square bit, okay?
Yeah.
So now we know that x squared minus 6x plus 10 is equal to x minus 3 squared plus 1. Yeah?
Yeah.
And now the next bit here is about using that and the rules of transforming graphs. So have you learned about the rules of transforming graphs?
Yeah.
Okay, well, if you know about the rules of transforming graphs, then certainly by the summer, say, I hope that you'd be okay with if you had y equals f of x,
Yeah.
and we did y equals f of x plus 1, that would just shift the whole graph up 1.
Yeah.
Happy? Now, in our case, we've got y equals f of x, but we're actually then doing y equals f of x minus 3 plus 1.
Yeah,
So we're
which
going to need
is
to know two rules. We're going to need
yeah,
to know
which
the
is
plus 1. Go on.
yeah.
Yeah, and
Right 3
right
and
3.
left
That's right.
1.
Well
Yeah.
done. Right 3. So the graph is going to move 3 along and 1 up, right?
Okay,
So
perfect.
that's the
Thank you.
vector, and it's a translation by that vector.
Okay.
All right, happy?
Yeah, thank you.
Very good. Okay. Okay, of course it is, Ed. Okay. Just watch the film and catch up, yeah?
Thank you, sir. Bye.
Okay.
Could you please help me on 23?
Yes. Does anybody want me to wait before I do 23? I'll tell you what, just in case anybody's working on 23, 24, I'll go back and I'll do this question first. Okay, Ria? And then
Okay, I need
What's
help.
up with-
I need help on that anyway.
Okay, so anybody who's following on question 21, the first thing to do is to make sure that you're happy with my red sentence here. And if you're not, then you need to talk to me now. Okay. So, pi r squared h. Well, h is 3r, right? So that's going to be pi r squared times 3r. Oh, wait a minute. That is 3 pi r cubed plus 2/3 pi r cubed. That should be a cubed there. Equals 792 pi. Does anybody have anything they want to ask about that? Right. Well, you can do different things here. I think if it was me, I'd probably divide everything by pi. 3r cubed plus 2/3 r cubed equals 792. Well, you can do different things now. I think if it was me, I'd multiply everything by 3. Get rid of that 3 on the bottom. 9r cubed plus 2r cubed equals, right, 3 times 792. That's 4752. Now, nobody's shouting at me, so are you really okay with this? Does anybody want to ask anything? The left-hand side is 11r cubed equals 4752. Does anybody want me to stop and slow down? Does anybody want me to go backwards? Is everybody happy? Divide both sides by 11 to get r cubed. 4752 divided by 11. I feel like I've made a mistake. Wait a minute. Okay, I wish you guys were a bit more shouty because everybody's let me make a mistake here. And now I'm worried that you're just going to cross out what you've written. I don't think you were working it out with me at all. You know I times by 3 here. Well, 3 times 792 isn't what I said it was at all. It's 2376, okay? So thanks for spotting my mistake, everyone. Does anybody have a question they want to ask, or is it okay? So now it's 11r cubed equals 2376. Divide both sides by 11, and r cubed equals 2376 divided by 11, 216. So cube root it, and now I know what r is. R is 6. Now, can I answer the question? It says, given that the solid has a volume of that, work out the height of the solid. Well, I've worked out r. R is 6. So what is the height of the solid?
Do you need to do 6 times 3?
Well, you could do 6 times 3, Ria. And that's what I did when I first did this question, but that's only the height of the cylinder.
Oh, okay.
So that's not quite going to do it. You're going to need to do 6 times 4, aren't you? Because that's another radius, isn't it? Up there.
Yeah.
So it's actually going to be 24, not 18, but it would be very easy to make that mistake.
Okay.
Yeah. Okay. Right. It is. What time did we start? We started at 6:15. Yes, we did. I'm going to put the work solutions and the mark scheme in the chat for anybody who wants to kind of ignore me and just mark their own. Okay. And then I'm going to, in a couple of minutes, do the last questions on the paper before I go to the beginning of the paper. But at least if I put the mark scheme and the work solutions in the chat, if you want to work independently of me, then you can. All right. So I'm just going to copy them in now, and then I'll go back to where I was. There we go. So have a look at those. But in a bit, I will go through the harder questions and then I'll go to the beginning. But if you want to ask me a question about one of the questions at the beginning, please do. Okay, we've only got 2 more questions. And then we're at the beginning. Right, I'm going to do question 23 in a minute. But if anybody wants to ask me a question about anything at the beginning, then you can. Or if anybody wants me to wait and not do 23 yet, then just tell me. Now, in question 23, we've got a kite. To be honest, I find it much easier to draw a diagram because then I've got half a chance of understanding what's going on. Okay? So, if I was stuck, if in doubt, draw it out, I would definitely be drawing a diagram. D is at 2, 7. That's the point D. And then the other point we know is B, which is at 10, 19. Okay. And we've got a kite. So the kite's going to look something like this. Look, it's going to have A to B to C to D, right? A to B to C. It's not very good. To C to D. It's going to look kind of like that, right? That size equal to that size equal to that. Because look, that's what it says here. Okay, so that's our kite. By the way, one thing you need to know about a kite is that this line here and this line here cross at right angles. So it's not the best kite in the world, is it? Because they don't really cross at right angles. But let's label that as a right angle. All right. And this one and the blue one goes through the middle of the red. Because look, if you think about it, here's a perfect kite-ish. Here's a more perfect kite, right? It's a rubbish one. Never mind. Kind of looks like that, right? And here's the line. That's the red line. And this other diagonal, it's even worse than the last time I tried to draw it. Anyway, they cross at right angles. Right. Maybe that wasn't a good example. So, in this question, you have to find the equation of the line AC, which is the equation of this line. Okay? So all they're really doing is they're asking you to find the equation of the perpendicular bisector of BD. They're asking you to find the equation of that line, which crosses halfway and is at right angles. Okay? That's the perpendicular bisector of BD. Now, there's a fixed way of finding the perpendicular bisector of 2 points. And yes, you could figure it out each time, or you could just learn how to do it. B is the point 10, 19, and D is the point 2, 7. Now, the perpendicular bisector goes through the midpoint of them. So the first thing I'm going to do is find out the midpoint. I'll call it M. M for midpoint, M. Halfway between 2 and 10, we'll add them together, divide by 2. Halfway between 19 and 7, we'll add them together, divide by 2. That is the point 6, 13. Now, if I want to know the equation of that line, I need to know two things. I need to know a point on the line. Yep, I know that. And I need to know the line's gradient. Well, I don't know the line's gradient, the yellow line. But I do know the blue line, I do know the red line's gradient, or at least I could work out the gradient of the red line. Let's count up, shall we? 7 to 19, the change in y is 12. 2 to 10, the change in the x is 8. Look at that. The gradient of the red line is 3 over 2. So what about the gradient of this line? Well, it's perpendicular, isn't it? So the gradient of that line is going to be the negative reciprocal. Swap it over, change the sign. Not 3 over 2, but minus 2/3. And now I know the gradient of that target line, and I know a point on the line. So I know that y equals mx plus c. So y equals minus 2/3 x plus c. And the point is 6, 13. So I know an x coordinate and a y coordinate. Shove them in. 13 for the y equals minus 2/3 times 6 for the x plus c. 13 equals, what is that? Minus 6, I think. Minus 2/3 of 6. No, it's not. It can't be. It's minus 4. Minus 4 plus c. C equals 17. Ah, so now I know the equation of that line. Y equals minus 2/3 x plus 17. Let's look at the question. Give your answer in the form py plus qx equals r. So I need my line in the form x plus y, something x plus something y equals r. No fractions. Times everything by 3. 3y equals minus 2x plus 51. Plus 2x's to both sides. Now I think I've got it how they want it. 3y plus 2x equals 51. Bob's your uncle, Charlie's your aunt. Now, ask me a question about anything on there if you want to. It's not very easy, but it's a bit easier once you realize it's just the perpendicular bisector they're asking. Everybody happy? Or have you, if you're not going for a grade 8, 9, 7, 8, 9, you might have cut your losses. You might not be even listening. Okay. By the way, everybody could try and draw the diagram and might be able to get 1 or 2 marks on this question. Nobody's stopping me. Shall I go through 24? Does anybody want me to wait? Okay. Do you remember for 24 how you can go from S, the equation for the displacement or the distance, to V, the equation for the velocity or speed, to A, the equation of the acceleration? How do you go from one to the other to the other? The answer is you differentiate. So here I've got the formula for S. Now maybe if you're just after part marks, maybe the minute they give you a formula for displacement, for distance, just differentiate it. Just write V equals and differentiate it. Now, do you know how to differentiate? That's going to be 3t squared minus 12t plus 5. Does anybody want me to explain how I got that? All I can see 2 faces, and otherwise you're just a sea of black rectangles, really. Now that's velocity, so to get acceleration, I'm going to differentiate again. 3 times 3t squared becomes 6t. 6t minus 12. There's the formula for acceleration. Does anybody want to ask me anything? Find the value of t for which the acceleration is equal to 3. Well, this is the acceleration, and it wants to know what value of t makes the acceleration equal to 3. Look, it's asking me to solve that equation. What value of t makes the acceleration, which is 6t minus 12, equal to 3? So 6t minus 12 equals 3, 6t equals 15, t equals 2.5. There we go. That's 4 marks.
That's quite good for 4 marks.
I agree. As long as, Isabel, you remember this bit. Oops, I didn't mean to scrub it out. As long as you remember, that bit.
Yeah.
And even if you didn't know what to do, if you just think, right, he said, if it's got displacement, then just do the velocity and the acceleration and differentiate, as long as you remember how to differentiate. That'll get you 2 out of 4. Okay? Bargain. All right? But look, if you got half marks on the last question of a paper, you'd be chuffed. Okay? And yes, you're absolutely right. It's okay. It's an okay last question. Right, everybody. So we've got about 20 minutes left. Of course, if you've had enough and it's 8 o'clock at night and you just want to disappear, then just disappear. But if you haven't yet gone to the easy questions, maybe spend 10 minutes on the easy questions. Or if you want to ask me a question about anything we've already gone through or about the easy questions, then just tell me. Yeah? I'll be quiet for 5 minutes.
Am I allowed to quickly go get some water?
Of course you can.
Thank you.
Sir,
Hi.
is it all right if I go now?
Yeah, of course it is.
Thank
You
you.
happy? Have you
Yeah,
got what sort of
very.
mark did you get, Jesse? Do you know yet?
I think a 7.
Wait a minute, let's look at those grey boundaries again. There you go.
Yeah, I think a 7.
Yeah, and were there bits that you could have got right to hit the 8?
Maybe, probably, yeah.
Have a look, see what those topics are, and just do 10 minutes on those topics, and then maybe, you know what I mean?
Yeah.
Have a look at what questions you could have got right, but you didn't, to get those extra 10 marks. Make sure you're safe on those topics, or tell me what they are sometime. Make sure you're safe on them, and then you should be okay.
Okay, thank
You
you.
with me?
Yeah.
Cool.
So I'm just going through the work solutions,
Yeah.
and on question 7b, I got 4 times 10 to the minus 3, but it says it's 4 times 10 to the minus 4. Could you?
Uh, have I made a mistake?
I'm not sure, but
Which question are we looking at?
7b.
Let's have a look. Well, it's 4 times 10 to the minus 3 is the answer.
Okay.
What do the answers say?
It says 4 times 10 to the minus 4. I'm sure. Yeah.
Well, fortunately, I've already passed my GCSE. But you're right, Rohays.
Thank you.
Oh, quite like this paper because there is, on the distance, speed, time, there's the opportunity for me to mention the daddy triangle. And dad's a saint, remember? And there's also a mass density volume question. So, I know, but it keeps me happy. I can mention the mummy triangle. Mum's a devil. My screen's just frozen, so I can't write that in at the moment. I will in a sec. Here we are. Mum's a devil. Right, so dad's a saint. We'll do distance, speed, time for you. And mum's a devil. We'll do mass density volume. Anybody want to ask anything? Oh, that's right, Rohays. The work solutions aren't mine. I've put somebody else. So it wasn't my mistake. Let's have a look. Oh yeah, you're right. They've got it wrong. I would do 7C, just stick it straight in my calculator. I wouldn't do what they've done.
Sir, can I go now, please? I've finished.
Yeah, of course you can. Are you happy, Rohays? Is there anything I can help you with?
Yeah, no, I'm really happy. You went through all the questions I struggled on, so that was
And
good.
what did you get, do you think?
I got, without the ones that I went through on the thing, I got 77.
Hey, well done. That'll do, Rohays. Very nice indeed. Good on you.
Thank
Cool.
you.
Yeah, go. See you next time. Does anybody want to ask about any of these apparently easier ones? Because if there's anything you don't understand on any of this stuff, then please ask me. And I'll- Did you get your 9, Avery? Good on you. Well done. Now, if anybody wants to kind of revise a topic before next week to try and get a 9 across both papers, if you see what I mean, let me look at next week's paper and suggest a couple of topics that you might want to revise. Because it's not really cheating, because when you do your first paper, you've got 2 weeks until your second paper, so we'll be able to spot what topics haven't come up in the first paper, right? So, simultaneous equations haven't come up on this first paper, right? Both the easy ones, and we haven't had simultaneous equations with quadratics either, have we? We haven't had SOHCAHTOA. We haven't had any vectors. We haven't had any surds. We haven't had any proportion. So there are some topics. We haven't had any 3D trig. Okay, so there are some topics that if you wanted to imagine, we haven't had functions either. So if you wanted to imagine that you were doing the paper for real, right? Then having done the first paper, then I'd probably be sending you a list of what topics haven't come up. And if I'd seen that first paper, then I would say the following topics. Write them down this time if you want to. I would say simultaneous equations, easy and hard. I would say SOHCAHTOA. I would say SOHCAHTOA in 3D. I would say vectors. I would say surds. I would say functions. And is that everything I'd say? That probably is everything that I'd spot that hadn't come up.
So
Oh, no, proportion, I said. Sorry, Ria?
algebraic fractions haven't come up.
No, they haven't. That's right. Yeah, that's another thing that hasn't come up. So if you want to play the game, then those are topics that if you fancy doing next week's paper proper, you might think, oh, I'll spend 10 minutes on each of those before next week. Anybody want to ask anything? Because we're going to finish quite soon, as long as you're happy. I'm happy to hang on if anybody wants to ask anything. I'm happy for you to disappear if you want to. Leave a bottle of red wine by the door. See you next time. Or stay on and ask me a question.
I finished, but it won't let me access the work solutions. I don't know why.
Okay. Has anybody else had trouble accessing the work solutions? I'll try and send it again, Ria. Obviously, Rohe's managed to access them because she found a mistake in them. So I'll try again. Here we go. Try that, Ria. Try that link. Any good?
Oh yeah, thank you.
Good. Okay. What'd you get, Beatrix?
I got 60 marks.
60. What would that have given you?
Is that in percentage or is that in marks?
Yeah. This paper was out of 100, right?
Oh, okay. All right.
And so obviously 62 is 62%. That's fine.
Yeah.
But really what happens is that those aren't the grade boundaries, right? The grade boundaries are double that. But of course, it's for 2 papers. So what did you say you got? 60? Yeah?
Yeah.
So if you get, what's that make? 125, right? On the 2 papers combined, then you get an 8.
Okay.
So if you've got 60 on this paper, then if you were to get 65 on the next, then you've got your 8.
Okay.
You with me?
Yeah.
Cool. Okay, well that's not a bad start, is it?
Yeah.
And especially as lots of people manage to get in the real thing, lots of people aim for more marks on the second paper because once we've got the first paper, we can target what topics haven't come up.
Yeah.
You see what I mean? Cool.
Okay, thank you, sir. I'm gonna go now.
Okay. See you next time.
Bye.
Okay. Anybody want a hand with anything before we call it quits? Ooh. Sorry, Thomas, have you been waiting for ages?
No, it's fine. I accidentally disconnected.
Oh, I'm sorry, but your mum sent an email 20 minutes ago. I've only just seen it.
No, it's fine.
Sorry. Right,
That's
what have
all.
you missed? What do you want me to run through?
No, it's just question 2 I was a bit stuck on.
Oh, right, let's have a look at question 2. Oh my, right, I'm not surprised because distance speed doesn't come up very often, right?
Yeah.
So what I do is I read it carefully and kind of understand the stuff as I go, right? So it says Jelena left home at 10 o'clock. So I can see that happening here, yeah?
Yeah.
To cycle to the park. Fine. On her way to the park, she stopped at a friend's house and then she continued her journey to the park. Now, this is the bit where she stops because between 11 and 11:15.
So, can I go?
Yeah, go. Between 11 and see you next week. Between 11 and 11:15, she's not getting any further from home, is she? Do you
No.
see that, Thomas?
Yeah.
So that's obviously when she's at the friend's house. And then look, after 11:15, she carries on getting further away, doesn't she?
Yeah.
Yeah, happy? Okay, so happy with that?
Yeah.
Right. Okay, so that's obviously the park there at the end. Right. On her journey to the park, did she cycle at a faster speed before or after she stopped at her friend's house? Well, do you know the answer or do you not know the answer?
Is it before?
Why?
Is it because the line's steeper before
Yeah,
the
that's right. Look, before she's getting further away from home quicker, isn't she?
Yeah.
Do you see? I mean, let's take a really extreme. Let's do a line that's like this. Look, this line, right? This person has covered in half an hour, has covered 25 kilometers, right? That's really quick. Do you see what I mean? Whereas
Yeah.
this person has covered in half an hour, has gone much less distance, haven't they? My red line. Yeah.
Yeah.
So it is the steepness of the line that tells you the speed, right? Okay. What happens next? She stays at the park for 45 minutes. Okay, here we go. So for 45 minutes, she doesn't get any further from home. So there we are. That's 45 minutes staying at the park, that red line. Happy with that?
Yes.
And then she cycles back, I think it's 16 kilometers an hour, is it? Yes. How are we going to draw that line? We know she starts cycling here at 12:45. 12:45. I don't know how steep to draw. Sorry. I don't know how steep to draw the line, though. Do you see my
Do you
problem?
do like 24 do you 24 minus 16?
That would be 8, yeah?
Yeah. And then you just draw the line, like you add an hour on from
Yeah,
12:45.
nice, nice. That's exactly what I would do. So adding an hour, right? So that's going to be 4 squares along, right? It's there. And after the hour, she's got to be 8. So, oh, it is going to be there, actually. Yeah? Is that what you were thinking?
Yeah.
So it's going to be like that, right?
All right. Okay.
Nice. Now, next. It says, work out Jelena's average cycling speed in kilometers per hour for the complete journey to the park and back. Do not include the time she wasn't cycling. Right. Distance, speed, time. It wants us to work out the speed. It's going to be the distance divided by the time, right? Happy so far?
Yeah. Okay.
Right. How long does she cycle for? Well, that's an hour in the yellow. Then it's another 45 minutes. You happy with this?
Yes.
And then it's that lot. Now I think that's an hour and 45, 2 hours, 3 hours. It's 3 1/4 hours. Okay.
Okay.
And then what about the distance? How far has she cycled?
We just add them all together.
Well, you could do, or you could do it a bit more simply. How far away is the park?
Well, isn't it just 24 times 2, right?
Yeah, 48. Nice. So her average speed is 48 divided by 3.25. And put that answer to 1 decimal place.
Okay, thank you.
Is that okay? Do you get where the 48 came from and where the 3 1/4 came from?
Yeah, thank you.
Cool. And that's that. Job done.
Sir,
Hi, Isabel.
how did you draw that line again? You know, the
Okay. Well,
16 one.
yeah. Well, the answer is I kind of figured it out, which isn't very helpful. So, are you okay with the flat line?
Yeah, I did that bit.
Right. So we're here. Now, we're gonna cycle at 16 kilometers an hour, right?
Yeah.
So, when we've cycled for an hour, we have to have gone 16 kilometers. Happy?
Yeah.
Right. Well, we start off 24 kilometers from home. So presumably after an hour, we're now going to be 8 kilometers from home.
Yeah.
Okay. So I'm here. I cycle for an hour. So I'm going to go 4 squares forward. And then at that point, I have to be 8 kilometers from home. So it's going to be here.
Oh, I see.
Do you see what I mean? That's why I
Yeah.
said it's a kind of bit of a bodge thing, really. You kind of figure it out. Do you
Yeah.
see? And then
Yeah.
you just carry on the line on the same gradient.
Okay, thank you.
Is that okay?
Yeah.
There's probably a better way of doing it. I just don't know what it is.
Yeah. No, that's okay.
So those of you who managed to leave the meeting and then it took me ages to let you back in again, have you got the links for the work solutions and stuff? Thomas, do you want the links? Have you got the links?
Yeah, I've got the links. Yeah.
Okay, cool. Right, guys, it's really time to go in that you've done an hour, 2 hours and 5 minutes of maths. But of course, if you want to stay and ask me anything, then of course, please do. But otherwise, I feel like you've served your time.
Thank you very much, sir.
Okay, no problem, Jake. See you next time.
Bye. Thank you.
Thank you very
Okay.
much.
No problem. See you, see you. Thanks for
Thank
coming.
you.
Sorry, sir. Is it okay if you put the worked answers in the chat again, just because I
Yeah,
have
of
to
course it
rejoin?
is. Yeah. Did you have to wait for ages to rejoin?
No, not too long, just like a couple of minutes.
I'm sorry about that. Somebody else had managed to do the same as you, and then their mum sent me an email and I happened to see it. Otherwise, you'd still be out there. Okay, here we go. So, oh, right. I think that should give you the mark scheme and the work solutions. Is the link working okay?
Oh, yeah, perfect. I've got it. Thank you. Have a great week.
Okay, all right. See you next time.